Can a person survive in space without a spacesuit? How much time will he live? Watch this video and you will know yes or no. Imagine, you are thrown out of the airlock compartment of a space station or a ship and you are without a spacesuit. You are in a panic and desperately trying to escape. Can you escape, and how much time do you have to find the source of air and the necessary atmospheric pressure? Very little, but more than you think. First of all, it is worth saying that you will not explode and your blood will not boil. Your body will not lose its integrity just because you are in a vacuum. You may have noticed something useful that covers you from head to toe. This is your skin. She does an excellent job with her work, keeps your insides inside. It is flexible and very durable, so you don't have to worry about bursting like a balloon. In addition, the skin will maintain your internal pressure high enough so that your blood does not boil. The temperature in space is minus 270 degrees Celsius. The temperature, or rather, its lack, will also not be able to kill you right away. In cold water, a person quickly cools. Not because of the temperature of the water, but because the water is a very good conductor of heat. All the heat generated by your metabolism immediately goes into the water from your body. There is vacuum in space, and there is no convection in vacuum, and there is no thermal conductivity either. The only way to lose heat is radiation. Each person glows in the infrared spectrum, radiating heat with a power of about 100 watts, like an electric lamp. On Earth, we do not even notice the loss of this energy since we are wrapped in a layer of insulating air around us, heated by the sun above the head and the earth under our feet. In space, there's nothing to isolate us with, so we might end up freezing to death. But, fortunately, the loss of 100 watts of heat is very insignificant in comparison with the mass of our body. A lot of time will pass in an airless space before you turn into a piece of ice. The weakest link is our treacherous circulatory system. There is no air in space, which means there is no oxygen. But your blood does not know this. It circulates through your lungs to pick up another portion of oxygen, and continues on its way, with or without oxygen. Our heart continues to beat, and oxygen-free blood disperses throughout the body. And of course, blood goes to the brain. With oxygen starvation, your brain goes into an energy-saving hibernation mode. 15 seconds after you leave the gateway of the spacecraft, you will lose consciousness. Nevertheless, you will still be alive. If some kind alien picks you up and takes you to a safe place within 1 or 2 minutes, everything will be alright with you. Well, apart from ableism and an unpleasant tan from hard ultraviolet radiation. This is not very pleasant, but will not cause much harm to the body. If you stay in space for more than 2 minutes, the other organs will cease to function due to lack of oxygen. In medical language, this is called death. An important reminder: underwater you can and should hold your breath, but once in space without a spacesuit, you should never hold your breath. Your lungs and airways are not designed to contain atmospheric pressure in a vacuum. If you hold your breath, you will encounter the same problem that divers face when climbing too fast to the surface: torn lungs. To understand exactly what will happen to a person in space, one could check this in appropriate conditions. But it is clear that no one will specifically conduct such experiments on people. But in history there are several significant accidents with astronauts. In 1965, space technician Jim LeBlanc tested the tightness of the suit for lunar expeditions in a special chamber. During one of the stages of the test, the pressure in the chamber was as close as possible to the cosmic pressure. The spacesuit was depressurized unexpectedly. and the technician inside it lost consciousness after 14 seconds. It took about half an hour to restore normal Earth pressure in the chamber, but in view of the dangerous situation, the process was accelerated to 1.5 minutes. Jim LeBlanc regained consciousness when the pressure in the chamber became the same as on Earth. Another example is the accident on the Soyuz 11 spacecraft. When the spacecraft returned to Earth, depressurization occurred. This accident forever entered the history of astronautics. The cause of the death of the 3 astronauts was a ventilation valve accidentally opened with a diameter of just 1.5 centimeters. According to information received from the recording equipment, all 3 cosmonauts lost consciousness 22 seconds after complete depressurization, and death occurred 2 minutes later. The total time spent in near-vacuum conditions was 11.5 minutes. After the spacecraft landed on the ground, it was too late to save the astronauts.